All right, so we're on continuing with simulations, and we're on page 9 of the note spiral. And once again, to expedite things, I'm going to utilize pre-printed answers, but to speed through things a little bit. So suppose the probability that an exploratory oil well strike is about 0.2. That's interesting. 0.2 means that's about 20%. And the fact that I'm working with a percent means that duplicates are probably going to be permitted. Unless it specifies otherwise, I'm going to believe that duplicates are permitted because we're working with percents. So conduct a simulation to answer the following questions. Assume the outcome, oil or no oil for any one exploratory well is independent of outcomes from other wells. Use the random number table below and conduct 20 trials. So here they're telling me that I got to do this 20 times. And the sad thing about this is I count this up and I don't have 20 rows, which means I'm not going to have row 1, row 2, row 3 be a trial. I'm going to have to continue going across. So it's going to be a little bit cumbersome, but I just wanted to show this example. And it says clearly identify each trial on the table. So the question they're asking is how often, describe a simulation and estimate the average number of wells that need to be drilled in order to strike oil. So we want to find the average number of wells that have to be drilled to find oil. So that's the question that they're asking. And basically the component is we're going to keep drilling until we find oil. As soon as we do, our trial comes to an end. All right, so we're going to keep drilling until we find oil, and we need to address our assignment. Well, I want to real quickly go back to random number table. Well, random number table has 0, 1, 2, 3, 4, 5, 6, 7, 9. Those are the numbers that are given. And if I can use one-digit numbers, it's easier than using two-digit numbers. Well, since I have 10 numbers, I need 2 numbers. Well, I'm going to choose 0, 1, but technically I could have chosen 1 and 9, 3 and 6. Any combination of 2 would give me 20%. Or I could have used two-digit numbers, but generally speaking, it's a lot faster if you can use one-digit numbers. One digits are always faster than 2 digits. So I'm going to use one-digit numbers. I'm going to say 0 to 1 hits oil, and 2 through 9 do not hit oil. And as it turns out, we don't have any skips. So here we go. I'll work left to right, choosing single digits numbers. 0 and 1 represent oil strikes, and 2 through 9 represent wells that did not strike oil. 20 trials will be run. I needed to address, and I did not do this, repeats are permitted. And since there are no skips, I don't have to say it. I can say that there are no skips, but repeats are permitted. So here we go. That's that. I'm going to go ahead and start running this, and then I'm going to swap over. Remember, 0 to 1 is what we're looking for. Well, a 4. Well, guess what? I didn't strike oil with a 4. All right. I didn't strike oil with a 7, but I did strike oil with a 1. So that's the end of my first trial. How many wells did I have to drill? Well, it turns out I had to drill 3. Then I have 6. That's a not oil, not oil, not oil. 0 is an oil. So I had to drill 4 wells, 1, 2, 3, 4. Then I got here, 4, not oil, oil. I had to drill 2. Here, hey, 0 doesn't oil, so I only had to drill 1 well. And so the simulation continues on. And here we had to drill 1 well. Here I had to drill, and I'm not getting it, I'm not getting it. And then all of a sudden, after 19 wells, I finally strike oil. I come over here, and I'm not getting it. And then here at 10 wells, not oil, oil at 2, not, all the way to 7 wells. And the whole time I'm making a list and making a table of this. Now your table is not going to look that nice. Obviously, I had time to set it up on a computer. One other thing I want to point out to you while you're taking a look at this is this one right here, because all of a sudden we had, okay, not oil and oil, that was 2. Well, that's what we've been doing. But then I get to this one, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Please notice I had to wrap around. All right, so I wrapped around, and that made 9 wells. So that particular trial took 9 wells. Now, it would have been great if I labeled my trials, but I didn't. But you can clearly see where a trial ended. Well, when I ended up running this thing, the first trial took 3 wells, etc. We had one that had 19 wells. That took forever. And when I added them all up, there were 98 wells drilled, and 20 of them contained oil. So 98 divided by 20 is 4.9. And that answered my question above. Based on the simulation, we would expect to have to drill an average of 4.9 wells to strike oil. I want to say something about that 4.9 that's kind of interesting. If it were 1 in 5, that would have been 20%. So basically, in this particular sample, we varied a little bit. Instead of being at 5, we were at 4.9, 1 in 4.9 wells. And that kind of shows the variation that a simulation will do. And depending on who did the simulation, what numbers were assigned, we're all going to get different answers. And that's kind of the idea of the simulation, is to show the randomness. Part B, what is the probability that it'll take fewer than 3 attempts to strike oil? What's the probability to take fewer than 3 attempts? Well, that means 1 or 2. Well, 3, that's 1. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that happened 8 out of 20 times, which is 35% of the time oil was struck in less than 3 wells. Okay, so 35% of the time is a pretty high percentage of the time you can expect to strike oil in less than 3 attempts. What's the probability that it'll take exactly 6 wells to strike oil? Well, in that case, I'm sitting there looking for 6, looking for a 6, and I have a 6 right here, and I have a 6 is the very last one. So 2 out of 20 times, or 10% of the time, I found oil on the 6th well that was drilled. All right, and that concludes this one, and we will do one more in the next video.